Okay, this gives you dx dt for an object moving along the xy plane. Okay, part A asks you to find the x-coordinate of the position. So you should be thinking, okay, I'm going to take the antiderivative or integrate dx dt with respect to t. That will give me the x-coordinate. And I want to know what happens at 4, so you should be using 4 as one of the other bounds. The only other bound time that you have information about is 2. So that should be the other value that you're using. So I'm going to use 2 and 4, and here's your fundamental theorem. When I integrate dx dt from 2 to 4, this is going to be x of 4 minus x of 2. So x of 4, which is what you're looking for, is really x of 2 plus 2 to 4 of dx dt with respect to dt. So I mean, you can go straight to here, but remember the idea is when you integrate something, it just gives you that net change. You have to add on the initial position, which is the 2 value, because that's the only value that you know. So I know x of 2 is 1, which was given, and then this, use your calculator, and I get 7.13299 as your x of 4. Okay, this is all they need to see, either this or this, and then use your calculator to punch it out. Part B, they tell you dy dt is -7, write an equation for the tangent line. As soon as you see those words, you're thinking dy dx. In parametric form, dy dx is dy dt over dx dt. They told you dy dt is -7. dx dt, I want to know what happens at t equals 2. They gave you dx dt, so I'm going to go ahead and plug this in as well. Now you can leave it like this if you want. If you want to punch it out, that's fine. I get this. And the point that I wanted to happen is at t equals 2, but at t equals 2, the coordinate is 1, 8, which they gave us. So y minus 8 equals -2.9833 x minus 1. So there's the equation of the tangent line. Part C, find the speed. Square root dx dt squared plus dy dt squared. Okay, just use your calculator. You know dy dt at t equals 2. They told us in part B at t equals 2 dy dt. So this, you're just plugging in -7 and squaring it. This, they gave you dx dt. Plug in 2 there, square it. Use your calculator. I get 7.38277. Lastly, part D. The line tangent to the curve has a slope of 2t plus 1. Okay, find the acceleration vector. So I need x prime of 4 and y prime of 4. This is what I'm looking for. Remember, your vector should have 2 components. So I need the x acceleration component and the y acceleration vector. The x piece is pretty easy. They're telling you dx dt is 3 plus cosine of t squared. So you just need to take the derivative of this and plug in 4 for t. It's up to you. You can do it by hand. You can just type in your calculator. You don't need to show any work because the calculator will do all this. So this is your x component of the acceleration vector. Now your y component, you do not have the first derivative. So what you need to come up with is the first derivative. So you need dy dt. But what they do tell you is that this has a slope of 2t plus 1. So that is your dy dx. They are giving you slope in terms of t. So what you should be thinking is, okay, they give me dy dx, but in parametric form, I know dy dx is dy dt over dx dt. They tell me this is 2t plus 1. dy dt is what I'm looking for. They know that they tell me that dx dt is 3 plus cosine t squared. So if I solve this, I can come up with an equation for dy dt. Once I have this, so they're looking for this, I can have the calculator take this derivative for me. So the second derivative, or the derivative of this, and plug in t equals 4 afterwards is 24.8136. So these are the 2 values they're looking for.